All right, we're going to start with quantum numbers today. So quantum numbers is basically a different way to express what electron configuration can. And the reason why we have quantum numbers is actually quantum numbers were used prior to electron configuration. And so it's kind of this, they were used and then we came up with electron configuration. So generally, we use electron configuration, but it's also important to understand quantum numbers as well. And so here's a chart explaining the quantum numbers. Hopefully you remember the principal energy level or quantum number is n. N is also the energy level. So you've seen n before. You can have 1 to 7. If you look at the periodic table, there's 7 rows. L is the angular momentum quantum number, and that is kind of an n minus 1 number. And that actually correlates to the SPDF sublevel. So all these quantum numbers actually relate to the electron configuration. Then you have the magnetic quantum number, which is m sub L. And the way it's labeled, they represent the orbitals. And we'll show you what that means. And then hopefully you remember what spin. Remember there's 2, according to Hund's rule, you need an up and down spin. That would be Pauli exclusion, sorry. So that's 2 maximum in each one. You have a plus 1/2 and a minus 1/2, which refer, the plus is the up and then the minus 1/2 is the down spin. So ideally what you're supposed to be able to do is you're supposed to be able to, each electron in each element has their own set of quantum numbers. And so the quantum numbers are given in groups of 4 with parentheses around it. So oops. The first number is always your energy level or your principal quantum number. Then angular momentum, L. And I put L as a cursive just so you don't get confused with 1, the number 1. M sub L, which is your magnetic number, and then M sub S, which is your spin. So oftentimes each electron we can do 1s1, 1s2, that kind of stuff. We can also represent them using these quantum numbers. And they'll go, so like you might see something like, 0, or sorry, you can never 0. So you might have 1, 0, 0, plus 1/2. And so I might ask you, this number represents, it's kind of like an address. It represents one of the electrons. So my question might be, this electron is the highest energy electron for which element? And so let me do it on the next one. So let's rewrite it. So you have 1, 0, 0, plus 1/2. So a couple things we know. And so let me translate to this. So this is energy level number 1. So that's the energy level, right? So it's an energy level number 1. This is the angular momentum, which is the sublevel. So you could write this if you want, but it's n minus 1 from the energy level. So 0 is equal to S. 1 is going to be P, 2 is D, and 3 is F. Okay? So like if I have 1, then I have n minus 1 there. So this is going to be S here. So this is 1s. So in 1s, we know that there's 1 orbital, which we're going to call the 0 orbital. So this orbital is 0. It'll make sense later. And then there's only 1 electron because we only have the up spin. Okay? And so, well, what is... and so this, ultimately, if you translate it into... it's 1s1, which is hydrogen. Let's do another one. So the next one, let's do 3. Let's do 3 2, -1, and -1/2. All right, so the question might be like, what is the highest energy level, or sorry, what elements, if this is the highest energy electron, what is the element that it's referred to? So here we have energy level. So I personally, I'll convert it into electron configuration. So this is 3. This is 2, so it's going to be D. And then this is -1. So in the 3D, you have 1, 2, 3, 4, 5. You have 5 orbitals. So we're going to label it. Middle one is always 0. And then you got -1, -2, and then -1 and -2. And then it's a -1/2, where? In the -1 position. So how do we get -1/2? Well, if I fill it in, it's going to be 1, 2, 3. But these are all positive 1/2s, right? 5, 6, 7. So this is 3D7. What is 3D7? 3D7 is 1, 2, 3, 4, 5, 6, 7. It's cobalt. So the answer here is cobalt. All right. So I think it helps to translate into the orbital diagrams. It helps me, and then I translate it and then figure it out from there. We can go the opposite way. So let me give you, for example, let's try arsenic. So arsenic, its highest energy electron will be 4p3. So 4p3. All right, so what's the energy level? It's 4, okay? P is 1, right? And then it's 3. So if I do this, so the 4p has 3 orbitals. So it'll be 4p3 is up, up, up. Let's label each one. Remember, you start middle 0, -1, +1, right? So then this third electron is in the +1, and it has an up spin. Okay? All right. So that's how that works. So the highest energy level for arsenic would be that. That would be the quantum numbers.